I would like to speak a little bit more in details about a solar engine compact. What is that? So we have here a solar panel that is covering this yellow compartment, and inside of it, come closer, I show you. Inside of it you have a compartment for all electronics, 2 batteries, all the cabling, so cabling going from the solar panel to the solar charger, cabling going to the output, input, electrical diagram in case you need to do some maintenance on the field. All components we are using here are top brand, which is Victron. Why do we have 2 batteries? The reason is, for this solar engine to be fully compliant with ICAO, you need to have a backup power source. So, which means that if this battery doesn't work, this battery will continue to work, and vice versa. What is inside of this compartment? What is actually managing the energy flow from solar panel to battery to any device that will be connected to this. So it's already unscrewed, so I will open it. And we are using only top quality brand, which is Victron. And those several devices, they are doing different things. Like this Phoenix Smart Charger, for example, is responsible for charging the battery using input AC power. Orion converter is used in order to, together with MPPT, is used in order to charge batteries from the solar energy. There you have battery balancer. You have also a monitoring device that provides us with the valuable information about battery charging. This small device right here, it's called ESP32, this one, and it's optional to the solar engine, and it is used in order to provide information about battery charging remotely to S4GA LCMS. So you can see, like, for example, here you have antenna, yeah, that is connected. That is basically through this port right here is connected to this ESP remote monitor. Sorry. For a technician to understand status of this solar engine, what you can do, you can download a special Victron app that is called Victron Connect, and then you can connect to the device and to see the status of this device. So I'm going to do it right now from my phone. I have already downloaded this app. So I will show you how it works. So here, right now, I have all the different devices that are in the network of my phone. And what I'm going to find right now is the device that is named D528. There is a default pin, so now I will go through monitoring and identify D528, which is here. Now I need to wait a bit, and what I see is that it has 100% battery, voltage is 13.5, current is 0.32 amps, power for 4 watts, and so on and so forth. Now, why do we have power drawn from this? Is because at the moment the solar engine, the sign that is connected to the solar engine is drawing power. Now, if you go to the history, you can see different, let's say, different statistics that you can use in order to understand the status, electrical status of the solar engine. You can see that the cable from the sign goes into solar engine. This one has 2 power output. This is a sign that is powered with 24 volt DC, and the power output here can provide maximum to up to 200 watts. Here is another cable going actually into the solar engine, and this one is currently connected to AC grid, which means that in emergency situation you can always recharge your solar engine using AC grid or generator powered. Very easy. You have a sign, you have a solar engine, you take this couple, install them anywhere on the airfield. There is no need for any special civil work, maybe excluding connecting the frangible mountings to the ground and also connecting solar engine to the ground.